Hello dear students, myself Mahmood Singh, Assistant Professor in Mathematics, Art Science, Commerce College, Lucknow. As you know that we are studying about application of Laplace transform in differential equation. Application to differential equation. Now, in this section we have studied the theory part, in which we have solved differential equation by using or by help of Laplace transform. In this lecture we will study about some examples, and the example is as follows: using Laplace transform, find the solution of using Laplace transform. Using Laplace transform, find solution of y double dash 25y 10 cos 5t, 10 into cos 5t. Now the differential equation y double dash plus 25y 10 cos 5t is given. This is differential equation which we have to solve by using Laplace transform. Let's start. Apply Laplace transform to the above equation. Apply Laplace transform to above equation. Then it will give us Laplace transform of y double dash 25y is equals to Laplace transform of 10 cos 5t. Since linearity property hold, therefore we can say that Laplace transform of y double dash is equals to 10 Laplace transform of 25 Laplace transform of y equals to Laplace transform of cos 5t. And by using Laplace transform of derivative, Laplace transform of derivative, we can write this expression as s square y of s minus s y of 0 and y dash of 0 plus 25 Laplace transform of y becomes y of s 10 as it is, and Laplace transform of cos phi t is equals to s square s upon s square into 25. Correct. Now since initial conditions are given as follows: y of 0 is equals to 2 and y dash of 0 is equals to 0. Then this equation reduced to s square y of s 2s minus 0 plus 25ys equals to 10s upon s square 25. Now taking y of s common outside, we will get s square plus 25 minus 2s, shift to right hand side, we will get 10s upon s square plus 25 minus 2s becomes plus 2s. And now from this we will get 10s upon s square plus 25 bracket square plus 2s upon s square plus 25. Now we have solution of the differential equation in the variable s. In this example, we have one differential equation with initial condition y is 0 is equals to 2 and y dash of 0 is equals to 0. And we have to solve this example by using Laplace transform. Now we have applied Laplace transform on both sides of the equation, and since linearity property holds, therefore Laplace transform operator distribute over addition, and we have Laplace transform of y double dash plus Laplace transform of 25y is equals to Laplace transform of 10 cos phi t. And we know that by using Laplace transform of derivative, we will get s square y of s minus s y of 0 minus y dash of 0 plus 25 y of s is equals to 10s upon s square plus 25. And by putting initial values in this equation, we will get s square 2s. Instead of writing y of 0, we have 2 is given in the equation, so we have minus 2s minus y dash of 0 is given as 0, so we write here minus 0 plus 25ys is equals to 10s upon s square plus 25. Now we want only y of s in left hand side, so s square plus 25 we have shift to right hand side, and we get 10 of s upon s square plus 25 square plus 2s upon s square plus 25. Now we want y of t, so apply inverse Laplace transform to the above equation, we will get inverse Laplace transform of y of s, then inverse Laplace transform of 10s upon s square plus 25 bracket square plus 2 inverse Laplace transform of 2s upon s square plus 25. Correct? Now here we have s square plus 25 bracket square in denominator. It is somewhat easy to understand. We can apply directly formula here to cos phi of t, but we have 10s upon s square plus 25 bracket square to get exact value. Since we know that 5 upon s square plus 25. Correct? And if we apply Laplace transform t into sin phi t, then we will get minus 1 raised to 1 power of t d by ds of 5 upon s square plus 25, and it will give us minus 1 minus 5 into 2s upon s square plus 25 bracket square. Minus 1 will become plus, it will give us 10s upon s square plus 25 bracket square. And if we take inverse Laplace of this, we will get t sin phi t. So therefore, in the right hand side, first term is t sin phi t plus 2 cos phi t. Cos 2 cos phi t. And it is the required result for our example. Now, we can take one more example, and example is as follows. Example is as follows. Example is as follows. D by d square, d square by d square plus dx is equals to 2 when x 0 is equals to 2, 3 and x 1 is equals to 1, where d square or power of d indicates the number of derivative. So we have to solve this example by using Laplace transform. So we have to apply Laplace transform to each side. We will get Laplace transform of d square, or we can write it as y double dash plus Laplace transform of y and Laplace transform of 2. Since we know that Laplace transform of y is equals to s square y of s, then s y of 0 and y dash of 0 plus y of s and Laplace transform of 2 will give us 2 upon s. Now putting the values, or we can say that since it is given in s, we can write it as since it is variable x, so we can write it as x double dash and Laplace transform of x and Laplace transform of 2. Correct? Now it becomes s square of say t or say s minus x of 0 s and s dash of 0. taking x of x common, we will get s square plus 1 x of s minus x0 is 3 is 3s minus x1 is equals to 1. So we can write it as 1 2 upon s. Now x square plus 1 x of s equals to 2x plus 3s plus 1 and x of s is equals to 2 of s square plus 1 plus 3s plus 1 upon s square plus 1. Correct. Now we can apply inverse Laplace transform to this, and then we will get s square plus 1. Yes, that's correct. Now apply inverse Laplace transform. Inverse Laplace transform. Then we will get x of t is equals to inverse Laplace transform of 2 upon s square plus 1 plus inverse Laplace transform of s upon s square plus 1 plus inverse Laplace transform of 1 upon s square plus 1. And we will solve this first term as I, and it will give us 3 of t plus sine. Now we have to solve the value of inverse Laplace transform of 2 upon s into s square plus 1. Part 1, that inverse Laplace transform of 2 upon s into s square plus 1, and which will give us 2 upon s square plus 1 equal to a upon s, and bs plus c equals to s square plus 1. So we will get a s square plus 1 and b s square cs equals to 2. Now putting s is equals to 0, put s is equals to 0, then we will get a into 0, 0, a is equals to 2. Now put or compare coefficient of s square, we will get 0 a plus b. This implies that b is equals to minus 2. Then compare coefficient of s only, then we will get c is equals to 2. So inverse Laplace transform of upon s plus minus 2s upon s square plus 1 plus 2 upon s square plus 1, and it will give us 2 into 1 as it is, minus 2 cos t and plus 2 sin t. Now putting this value here, we will get 2 minus 2 cos t plus 2 sin t plus 3 cos t plus sin t, and which will give us 2 plus cos t plus 3 sin t, and it is the required result for this example. In next lecture we will see some more example and try to crack some more advanced example by using Laplace transform. Till then, keep studying, keep watching video. Thank you.